Hi everyone, this is AC7WH Backyard Ham Radio. I wanted to present an analysis of the experimental cross antenna multi-loop design that I've been working with. So be sure to check out my previous videos and you'll be able to see more about it. So with that, it is resonant on a few different frequencies. Now, for those who might not know, a resonant antenna is one where the capacitance and the inductance cancel each other out. It does not necessarily mean that the impedance is 50 ohms like your transceiver is typically going to be expecting. However, the antenna is naturally resonant when those two fields, the capacitance and the inductance, are canceling each other out, and so the antenna is going to be most efficient at that particular frequency, even if maybe the impedance is, let's say, 600 ohms, which would be a 12-to-1 SWR if we're talking about 600 versus 50 ohms. However, the antenna itself can be efficient. So that's where an antenna tuner comes in, or like a 12-to-1 balun, or those sorts of different things, which have a very similar effect from everything that I am finding and confirming. Now, of course, that is a topic up for debate. Is it better to have some kind of a balun instead of an antenna tuner, or do you want both? Well, one way or another, you are tuning the overall antenna circuit, not the antenna itself, unless you are physically changing something with the antenna, as I've mentioned in a previous video. But in any case, I do want to show you how this antenna measures up. So a resonance point here is at 28.555 megahertz. So that would be really nicely almost smack in the middle of the 10-meter band. I am looking forward to really testing it there. However, I was able to use my Palstar HF Auto tuner, and I was able to tune up on every band that I tried from 160 meters to 6 meters, and I was getting a tuned SWR of as nice as somewhere around a 1.0 to 1, and in the worst case scenarios it was closer to a 1.5 to 1. But in any case, I was using it for transmitting on lower frequencies. I want to say it was the 40-meter band and the 20-meter band that I did transmitting on. Actually, the 80-meter band as well. I don't remember for certain on the 20-meter band. But in any case, I was using some of the lower frequencies, not the 10-meter band. So hopefully this weekend or sometime soon I can try it on 10 meters. As you all may have guessed, even without seeing any of my previous videos, a multi-loop antenna using even 14-gauge wire, American wire gauge size, is not that great of a radiator. That's why the professional high-power so-called mag-loop antennas are large, basically tubes that are used to really carry the current and minimize the losses. But I was just using wire like you would use with a nice wire antenna. And so with the multi-loops and the standard wire, probably a lot of my signal was just eaten up in heat through the coil of the wire with the multi-loop. But it was still nice to have a QSO using that antenna on 40 meters, but it was very local. I mean, just across town. But nonetheless, that was pretty cool. But for reception, I was able to hear South Africa, as I also mentioned in a previous video. And I heard South Africa quite clearly, so well over 10,000 miles. So over 16,000 kilometers. So it does work for both transmitting and especially for receiving. Super quiet for reception, but I think one of the main reasons for that is because even when it's tuned up and all of that, a lot of the signal is lost, and so it eliminates all the noise. And as long as you have a really strong signal, like what would normally be an S9 plus, you may have it as like an S4 and S5, and no static basically, because that's completely attenuated, almost like turning down the RF gain or turning on an attenuator of some kind with a transceiver. But anyway, let's do a little bit more examining here of my results. So if I take a look at the SWR, the SWR here at 28.555 megahertz would be a 7.88 to 1. So that means this would be somewhere around 400 ohms of impedance when the antenna is at resonance. So a lot of people would use something like an 8 or 9 to 1 Valin of some kind. I know 9 to 1 off the top of my head is a fairly common configuration, but my antenna tuner was able to tune it, so rather than utilizing that sort of a transformer coil, which wastes, so to speak, some of the energy, I just used my tuner, which could be arguably wasting some energy. But anyway, I could go into all the details and talk for a long time about this, but I find it fascinating. Let's just go ahead and look at a few other resonance points, and then we'll wrap up this video. Okay, so resonance at 28.555. If we keep going here, next lowest down is a resonance of 17.008. So that would be around the 18 meter band. Let's see for our next one. 5615. So that's not really in any particular band. And that's as far as we go there. Okay, let's look at some SWR examples. So on some of the lower frequencies, really high SWR, but it does dip down a little bit. So if you have a tuner that can tune at, for example, a 10 to 1, can tune up a 10 to 1, then it would be at about a 1.45 to 1 SWR here at this particular frequency if that was on a ham band that you were trying to transmit on, which it is not quite. But you can see the blue bars here again where those are the ham bands. So not too terrible, easily tunable, but kind of wasting the energy, I would say, for the present design, at least on the lower frequencies. Again, we'll see how this does on the 10 meter band. It seems like things are going to be the best there. An SWR that's easily tunable with my tuner and a resonance in the middle of that band. So we'll see how it goes. In this particular case, the minimum SWR in this part of the screen is a 5.6 to 1. So that is above the 10 meter band. But in any case, we'll see how this goes. And many of you already know this, but just keep in mind, a resonant antenna does not mean a perfect SWR antenna, if that's a thing. And also keep in mind that a perfectly, so to speak, perfectly tuned SWR and perfect resonance does not necessarily mean an efficient antenna that's really going to get your power out as RF where you want it. All right, well, thank you all for watching this little video, and 73.